Well, hi everybody. Welcome to session 3 of the Joy of Coding here at Portland State University. Hope everybody had a nice weekend. We're now in week 2, and we've got some cool stuff coming up this week. So we're going to be learning all about test-driven development and unit testing. Talk a little bit about integration testing next week. Um, and I hope that this content it gives you a better idea of how you can validate that the code that you write does what it's supposed to, which is something I think we all want, right? We want to write code that's high quality. We want to write code that does what we expect it to do and what others expect it to do. And I found the best way to do that is to actually write other code that demonstrates it. And so that's what we'll be doing tonight and on Wednesday. And remember that Wednesday, there is no in-class session. I will not be here. I'll be teaching remotely. It's the day before our holiday, right? And I figured it's a good time to not have to come downtown so that we can get our holiday off to a potentially early start, or at least not a late start. So please join the Zoom next week. Before we dive into test-driven development, I want to open up for Prime Minister's questions. So we've had the first week. Last time we talked about the Java koans and saw how to do that. How are people finding them so far? What's the experience been like, and what's your initial reaction to either the koans, the Java language, or the kinds of things you've been doing? Good? Yeah, like it. There's some thumbs up here in the classroom. Yeah? Yeah. Good. I'll get the chat up here, see if anybody's joining in on chat. Oh, good. Got a couple of thumbs up. Thanks. Any questions? Anything surprising when it came to either the language or the kinds of things the koans were asking you to explore? Yeah, yeah. Koans, they're koans for like every language out there. Yeah, right. And it's actually I too like it as just a bite-sized way to explore a language or an API or different concepts. So yeah, so if you're in another class, you need to learn another language, go see if someone's done a series of koans to help you just learn the nuts and bolts of getting started with it, and then from that you can build much more expressive things. Great. See here, works kind of similar to the languages I am more experienced with, intuitive for me. Okay, good. Glad you're finding Java relatively intuitive. I mean, the intent is, hey, if you've learned C or C++, then sort of the braces and the function declaration syntax ought to be familiar. The whole notion of a typed language ought to be pretty familiar. So good. I'm glad you're finding that it's relatively easy to get off the ground. It's the entire intent is that we spend the first week just learning about the language, and getting more experience there. Let's see here. If we have extra time during a free summer, what do you think about learning Swift simultaneously to tackle some of the assignments in Swift? I mean, not part of the course and everything. But yeah, I mean, I think being able to compare either Swift and Java or Swift and Kotlin, or just more generally the iOS development environment with the Android development environment is a good thing to do. To understand where they borrow from each other, and really, what are the differences that make a difference between the ecosystems and the tooling that comes with it. So, it's good to understand all of that. Okay, well, cool, Andrew. Yeah, thanks for volunteering to talk to Tommy about that. Very good. Let's see, a couple other things came in. I'll post a couple of things. Oh, garbage collector. Yeah, seen sometimes in the short term, but I can imagine it causes them in the long term. Wondering if you have any thoughts. Well, I think it depends on what you consider a problem and what how the problems might outweigh the benefits. So yes, it's true that when compared to a highly optimized, memory efficient native program, yeah, Java's not going to necessarily be as fast or use as little memory. That being said, for many years, Java has been run on embedded devices. Java was actually taking me back. Java was originally developed to be a programming language and a deployment environment for set-top boxes, like cable boxes, right? Back in the mid '90s. And they quickly realized, like, well, and then this whole internet thing came along, and they're like, wait a second, no, we can use this language for so much more. So, the garbage collection, yeah, is another thing that you need to worry about with your. Well, not you need to worry about it. It's another thing that as you build large-scale Java applications, you need to be cognizant of it. And just because there's garbage collection doesn't mean you can't get in trouble with memory. Right? You can still have memory leaks in Java. Right? All a memory leak is like, hey, you create some objects and you put them off someplace and you forget about them and can grow over time and take up more space. So Java, the garbage collector doesn't prevent you from doing things that are dumb. But what it does is it doesn't eliminate dumb things. It just makes it much more difficult to do the dumb things. And so the fact that you don't need to explicitly allocate and deallocate things, and it's much easier for data to leave the scope in which it was created, does offer a lot of benefits. So it's overall, I think it's much better. I think it helps me go much faster, more confidently. But hey, in some environments where there's a very restricted memory or very restricted CPU, and you have to be extra careful about having a thread go off and do extra work, or having to pause things while garbage collection happens. It's all good things to consider. Nice. Okay. Yeah, good questions. Anything else on your mind? Okay. Yeah, let's talk about test-driven development. Show of hands, and please raise hands in Zoom. How many of you have learned about testing and unit tests and things like that? Well, a couple people, yeah, a little bit. And, oh yeah, a little bit in CS302. Good. Ethel's done some unit testing. Sweet, yeah, I guess some other people. Okay, good. So hopefully you've seen it before. Test-driven development, though. How many have done test first? No, no test first. Well, good. That's what we're talking about here. Is right on, Ethel. Yeah. So what we're going to be talking about is a technique for approaching development in where you say, well, there's a problem that I want to solve, and I'm going to codify that problem in some code, and then I'm going to write some other code to solve that problem, to basically implement the test and make it pass. We'll be exploring this tonight using a simple program called the student program. It's kind of like your projects that we'll be learning about on Wednesday. And I've got a Google Doc that we'll follow along with. I'll post it here in the meeting chat and then also in Slack. For tonight's class. And by the way, if you haven't joined the Slack channel already, please do so. It's where I post all of the information. So let's do some of this stuff. So how we're going to explore test-driven development is with this student program. So student is a very simple class. It models a student. It has a simple command line program that will create a student and print out the student's toString value. Really, it's meant to just do some TDD. And however, to get us ready for writing unit tests, we're going to talk about some of the scenarios for interacting with the student project. Now, when it comes to finding the scenarios, the technique and the framework that I like a lot is, okay, questions going on in the background, is using given, when, then. So this for me describes the scenario that I want to implement in my test. So there are three aspects to it. There's the given, which is the initial context, the initial conditions under which the software is run. This is sort of the thing that you just set up your test. The when part is the behavior that triggers the scenario. So it's like the thing you do. So it's like, okay, great, I'm going to create a bunch of data, and they're going to act on that data. And then there's the then. So the then is what you expect to happen after you perform that behavior. So it might be one thing, it might be multiple things. So these are the side effects or the outputs or the changes that occur when you perform that object, when you perform that action. So sort of conceptually, as you're writing a test, you have the given, the when, and the then. Now, this is, this can be applied to code, but it can also just be applied to like any scenario. As a matter of fact, one of the things that occurred to me is that given, when, then is super helpful when you're describing some unexpected behavior. So like when you're, filing a bug report, or when you're making your IT ticket. It's like, hey, listen, I tried, okay, I went to the website and I entered my username and password, and when I clicked submit, well, I expected to be logged in, but actually I got this other error, right? It's that same pattern, and it's super effective for communicating some situation, some scenario. When you're filing, I suppose, when you're filing like a bug report, it's given, when, then. Well, it's given when I expected this, but that actually happened with something else. But anyway, it's the whole idea of, you want to describe the situation that you were in, the operation that performed, the action that you took, and then what you expect to happen afterwards. And if you let's see here. And when in these scenarios, the idea is that you're communicating it in a way that another person can understand. Another person might be you, if you come back to things, a little bit later. But it also can be for someone who isn't necessarily a developer, right? You may be working with a business stakeholder or someone who isn't necessarily writing in the same language that you do. And so then capturing them in plain English is definitely the way to go. There's a technique called behavior-driven development that is very akin to test-driven development, but instead of like unit tests that are at the code level, this is more about the behaviors that you expect. And this is basically a way of programmatically describing these given, when, then scenarios. And there are these languages and tools like Cucumber and JBehave that allow you to author these scenarios in a way that they can be executed. So you can then validate the code that you wrote against them. Now, we're not going to get into those tonight. Maybe someday in the course, or if I ever teach a course that's more really focused on test-driven development, we might talk about those. Instead, what we'll use is the JUnit framework and the Hamcrest library for implementing unit tests. I hope you all had an opportunity to review the lectures and the screencasts for JUnit and Hamcrest before class tonight. I've got some resources here if you want to learn more about it. I encourage you to do so. Add them to your list, or just take a few minutes to sort of skim over them now to get a better idea of what BDD is all about, because we'll be focusing primarily on TDD tonight. So tonight's class will be a mixture of interactive small group activities, and then watching me code and some talking back and forth while we're doing all of that. The first thing that we're going to do, we'll break up into small groups for about 20 minutes and review the Project Zero assignment. I'll skim through it quickly now and then give you all an opportunity to dive in more deeply. So we'll be writing a class called Student, and actually don't code anything yet. There's a way to get started, and I'll show it to you after we do some brainstorming. This actually originally was like the first project that I gave in the class many, many years ago. We had them do this, and I realized that project one has so much similarities, it didn't make sense to have a separate project. The whole idea is that out of the box, you get this student class. So this is a class in Java, and it extends human, which is actually one of my classes that I wrote. And we'll have you'll have your own student class. And what I'd like you to do is spend a few minutes reading over this assignment to get an idea of what the student class is all about. And in particular, let's see here. Oops, sorry, I didn't update that URL. In particular, I guess, yeah. So it's got a main method. So we haven't really talked about executing Java code, and we will maybe tonight or maybe on Wednesday. But the whole idea is that the command line tool takes some arguments, and the first one is the name of the student, then the gender, their GPA, and then 0 or more classes that they take. And then depending on the input arguments, ultimately what you're looking to do is to print out a value of the toString method implemented by the student, which, given that input, the Dave Mail 3.64 algorithms operating systems in Java, the program should print out, Dave has a GPA of 3.64 and is taking 3 classes, algorithms, operating systems, and Java. He says this class is too much work. So that's what your program ultimately does, those kinds of things. Anyway, so this is what the assignment might look like. So what I'd like you to do is break up into groups. First of all, look at the student class, and then brainstorm and capture some usage scenarios. Again, applying this given when then thing that we talked about very briefly up above. To really explore what the requirements of the assignment is. Sorry, the assignment are. And so then some of the groups, and we'll probably have 2 groups here in class. One of the groups will focus on the scenarios for the student class itself. So what should happen when you invoke the says method or the toString method, those kinds of things. So you'll be looking more at the code here and trying to figure out, hey, when I create a student object with these, with some specific arguments, then, if I invoke the toString method, what should I get? So some people will focus on that. And then other people will focus on more like the command line program. So, hey, when I provide these arguments to the command line, here's what should be written to standard output, here's what should be written to standard error. And so we'll take a few minutes and brainstorm all of that. And I've got 2 tables here, editable tables in the Google Doc that enumerate a bunch of test cases. And so the whole idea is that the groups that are working on the student class, which will be some part of this room and the odd number of breakout rooms for people on Zoom. So you populate this saying, hey, when I create, or given I have a student instance that's created with this name, these classes, this GPA, and this gender, when I do something with that student, then that thing returns a certain result. And here are some examples that I've populated here. Similarly, for the students who are working on the command line program, so these would be people in the even numbered breakout rooms, and then one of the groups here, when you invoke the command line program with certain arguments, then something's written to standard output, something's written to standard error. So it's giving us an opportunity to explore the requirements of this program from 2 perspectives. The first one's more internal. The first one's more about, hey, here's what the code is doing, and here's how the code operates under various conditions. The second one's more external. When it's taking input from the user on the command line, here's what it does, and here's what I expect it to do. So after you've had a chance to work together in groups, we will reconvene. We'll discuss some of the scenarios, and then we'll start doing some test-driven development. I'll be doing the coding, but I'll be asking you for input on what to write and which scenarios it makes sense to implement in which order. So that was an introduction to our activity tonight. Any questions before we divide up into groups and get started? Nope. Okay, so I'm going to pause the recording, create some breakout rooms. Thank you, and I'm not screen sharing. Thank you for letting me know. Sweet. Okay. Okay. I had to check in with each group. Apologize if the instructions weren't as clear as you would have liked. I know that I've been known to do that, so please raise your hand and call timeout. But I did leave myself a note for next time I do this to like, hey, let's do an example scenario for each section altogether. So next time it'll go a little bit better. But you all figured it out, and I see a lot of really good test cases for us to talk about and to explore and implement. But I want to hear what the experience was like. So, working together to brainstorm these things. What are some of the things that you experienced? What are some things that you saw? Anything surprised you? Anything you're like, it sucked? Yeah.
A minute to get the ball rolling, but once it started going, and then once you kind of figured out what to do,
yeah. Nice, yeah, and this often happens in groups, right? It's kind of quiet for a while, and then, okay, yeah, so people are figuring it out, and so, yeah, conversation happens. Great, great, great. Anything from the group over here that was focusing on the student class? Yep. Getting started, yeah. Okay. So you've got a couple of comments in here. Oops, let me make it bigger. Yep. Oh, and a request to get live subtitles. Okay. Yeah. Let's see here. How do I do that? Actually, can I do that while I'm sharing? Not under audio. Does anybody know how to do live subtitles? Okay. Yeah. If you could send me a Slack or something, and I'll figure it out for next time. Or maybe I'll do it during break. Shift computer sound. Yeah, things have changed too well. Anyway. Other comments. People who are remote. What was it like working in a breakout room with people? Let's see here. When I think about that, one question could be about what makes good pre-done tests. What kind of scenarios should we be testing for? Well, that was kind of the whole idea. I think this is scenarios that matter. This is an exercise in creativity and thinking, hey, what are sort of the happy path scenarios, things that you expect to go right all the time, and then as I was talking with one of the groups, what are the exceptional scenarios? What are the scenarios that speak to how input should be validated, the kinds of interactions that you should be thinking about? So I think that's it. So understanding the problem by saying, well, what happens if this happens? What if this? What if that? What if the other thing? Okay. Any other thoughts before we get started? We go to the next thing. Okay. Next, now it's time to do some test-driven development. And I've got a video that I think explains it pretty well. It's from Bob Martin, who has a series of videos called Clean Code oops. Great, thanks. And sorry, Ethel, could you send me that in Slack, please? Because the chat will just disappear on me or I'll forget about it. But I'll follow up in Slack, definitely. Not a problem. So, oops, sorry. Don't sign into Vimeo. Don't join free. So this is a quick little video where Uncle Bob shows how to do some test-driven development and shows this red-green refactor cycle that he goes through. And this is the technique that we'll use tonight when we implement some of those test cases that you identified. Oh, I don't think I'm sharing computer sound. Wait a second. Can I do that from here? Let me stop sharing. I'll share the computer sound so you can all hear it. Share sound. Share the desktop. Share the right desktop. Used. Come on. There's the right window. Here we go.
Oh, it's...
Could people who are remote hear that okay?
Yes.
Yes? Good, good. Thank you. Yep, we're getting lots of yeses. Sweet. Okay, good. Got the audio going. There we go.
It's time for the red-green refactor cycle. And I am in the red phase. I must write a failing unit test. All right. What test must I write that will force me to write public class game? Well, I'm going to write can create game. Game G equals new game. Oh, heavens. Thank you, IDE. Helpful IDE. That's enough of that. Heavens to Murgatroyd, that doesn't compile. Well, I must make it compile. So now, I'm going to create the class game. Yes, in the current package, there it is, the class game. And if I go back to my test, oh, look, the test passes. It's time for me to go to the green phase. I am now green. And in the green phase, it's time for me to refactor. Is there anything I can refactor here? No. Nothing to refactor. Very good. Then I am done with this test. I am passing. Lovely. Back to the red phase. The next test, well, I know I want to write that roll method. All right. Test can roll. Oh, heavens, I need a game. Game G equals new game. Lovely. G dot roll. What should I roll? Well, let's roll a 0. That doesn't compile. Okay, time for me to focus on making it work. I'm going to create the method roll. Ha! Look at that, roll. And it should take a pins. This is lovely. And I believe that will pass. Because I'm not actually testing anything. Oh, time for me to refactor. I've got a passing test. What's to refactor? Oh, goodness, I've got duplicate code here. Duplicate code. Well, I better take that and refactor that out. I'll create a field named G. I will initialize it in the setup method, which of course I don't have, but this will create. I'll keep it private. Lovely. So now I've got a nice setup method. It's going to create the game. It'll put it in the private field G. Can create game is now empty because, well, it doesn't do anything. And I think I can get rid of that line of code in can roll. And all of this should still pass. It does. I think I can get rid of that empty test now. This is common, by the way. You write a test just to delete it later. Lovely. Next most interesting test case. Back to red. Well, what can I make fail now? Oh, I got to write the score function. But I can't call score until I roll a complete game. Okay, so here we get into some of the technicalities of test-driven development. When you must write real code, you write the simplest real code you can. In this case, I'm going to have to roll a complete game. What is the simplest, most degenerate complete game that I can roll? A gutter game. Let's roll the gutter game. Okay. 4 int I equals 0, I less than how many balls in a gutter game? 20. I plus plus. G dot roll 0. That will roll 20 zeros. That is a gutter game. And now we will assert that the score is 0. Oh heavens, that doesn't compile. I must make it pass. Excellent. I will make this compile. It should return an int. I'll have it return a -1 because I still want to see it fail. It should fail. Yes. And now I will make it pass by returning a 0. This is stupid, but it's also easy. And I have now seen my test both pass and fail. I know my test works. It cost me nothing, but I now know that my test will fail if I don't get a 0. Well, that was nice. What is the next most interesting test case? Or is there any refactoring to do? No. Next most interesting test case.
Okay. That was Uncle Bob. So what did you notice in that 6-minute video? What are some of the things that stood out to you other than the hat about his approach to test-driven development and the kinds of things that he was demonstrating? Someone in chat. I was going to say the hat. Okay, yeah, sorry, I took the hat out of your... Yeah, you couldn't get past the hat. I get it. Yeah, he started off incredibly simply, right? And it was the, hey, I'm just going to write a test, and like all it's going to do is create an object. Well, it's not going to fail. Maybe it does, but what if it did fail, right? What if you found that you couldn't create your, class under test? That's actually a pretty important thing to be able to do. Yeah. Oh, yeah, great observation. So he only wrote as much code that was absolutely necessary to get the test to pass. It wasn't the full implementation. It's only enough code to get the tests that have already been written to pass. And that's a really important aspect of test-driven development. And this is something that takes a lot of discipline because you're all excited about the solution. But oh my gosh, I have written so many fewer bugs and actually just written fewer code. Because I've said, hey, wait, all I need to do is get these tests passing. And the cool thing about test-driven development is that you know you're done when all your tests pass, and you can't think of any other tests to write. Okay, that's great done criteria right there. Awesome. Oh, is like programming to the interface? Kind of. Basically saying, oh, great, I've exercised that interface completely, therefore it's implemented. I think it's like that. Yeah. Let's see here. Yes, the refactoring. So, did you pick up on what refactoring is all about? Yeah, he had a good example of, let's say, hey, getting rid of duplication. The whole idea of refactoring is that you make changes to the code that improve the internal quality of the code without changing the external behavior. And by internal quality, this is things like readability or organization, so that you can extend it more easily, so that it's more approachable by yourself and others. And in a couple of weeks, we'll have a whole exercise which is dedicated just to code refactoring. Let's see here. Yeah, if you had to code, make it as simple as possible. Right. Test-driven development is all about simplicity. It's all about lowering the cognitive overhead of what we do. We're all attracted to complexity. I know I am, right? It's like, oh, computers, all this, crazy stuff all going on at the same time. However, oh boy, that can make you tired. And oh boy, that can slow you down. Yeah, oh boy, that hurts that for a while. So, the cool thing about technically test-driven development is that you take these baby steps, just like you do with your cones, right? The cones are so straightforward because you just focus on one thing at a time. You just go, 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 go. Test-driven development is a lot like that. You think of these simple micro scenarios, and then after you've written a couple dozen tests, you realize like, oh my gosh, I've got like this big program here that is completely validated. That I know is 100% correct because I get all this feedback telling me so. Yeah, so yeah, right. So Ethel's like, hey, I want to see where this is going. It's kind of interesting, but that's right. Watching, test-driven development is more about a journey of going back and forth. When we do pair and mob programming, you'll be able to see how other people, how to work with someone else to go on that journey, and then how to go, on that journey with a group. Yeah, great. Some other examples of refactoring. Yeah, okay, tackling technical debt before it gets too out of control. Yeah, good, good, good. Okay, awesome. So again, it's this red-green refactor cycle. As a matter of fact, I've got some stuff in the handout about that. So let's talk about that. So, so test-driven development is actually not something that comes naturally to most people, especially those of us who are more excited about making the solution than testing the solution. So it's okay. It's natural to get excited about what it is that you're doing, and oh wow, look, I've got this great algorithm in mind. It's like, oh, this is the data structure that I want to build. Yup, but you'll be able to do that, but you want to make sure you do it right, don't you? And what better way to make sure that you do it right than to have tests that verify it? So then you want to be able to write code in which you can, make changes, introduce support for new scenarios without breaking other things, and make sure that just along the way the code always behaves as you expect it to. Also, as we talked about, we want to refactor along the way, clean things up, right? Make things more extensible as you go, and if you don't test, you might find that you've written a lot of code and not really understood the problem that you're solving. I've made that mistake so many times. I find test-driven development helps me explore the problem at just the right time so I can implement the right solution for it. So, and actually, the thing I really like about test-driven development is that I don't write bugs anymore, right? By the time I share my code with others, I can demonstrate that it works. As a matter of fact, the only time I have a bug is when there's a scenario that I didn't test for. As opposed to like, oh, I thought I had this test covered, and I thought I had this scenario covered. Maybe I did at one point, but then I broke it and didn't realize it. So, so test-driven development is not just about verification. It's about leaving your code in a state so that someone else, maybe you, can pick it up. So there are a couple of rules of TDD that Uncle Bob put out there. So the only way that you write any production code, which is the code under test, is to the only reason that code should exist is to make a failing test pass. Again, you write the test first, so the only reason to implement code is to make a test pass. And when you write a unit test, let's see here. Oh yeah, okay. You're not allowed to write any more of a unit test than is sufficient to fail. So unit tests are meant to be small, right? Only focus on a particular interaction with an object, a particular piece of functionality. So you want to write just enough of that, just enough of a unit test so it fails. And that includes compilation failures, right? Because sometimes the way you make a test pass is just it things compile. And then the third sort of rule that he put out there is that you are not allowed to write any more production code than is sufficient to pass the one failing unit test. I mean, ideally, you should only have one failing unit test at a time. It's that new one that you wrote. And so then just write enough production code to make that test pass, and then go through and refactor to clean things up. And then you've got your whole suite of unit tests that you can run after you refactor to make sure that you haven't inadvertently changed any capabilities. So, I know a lot of us don't think about coding this way, but I encourage you to try it out. Once you get used to these constraints, you'll find that coding is faster and easier, which seems completely counterintuitive, but that really matches my expectation. So a question, so if a function has multiple possible outcomes, would you only test and write the code for one outcome at a time? Yes. Trying to think of an example of a function with multiple outcomes. Well, maybe the outcome is different based on the inputs. And so then you sort of go scenario by scenario, and you get it working for so you write one test, get it working from that, write the other test, see it fail because the code under test isn't implemented yet, and get that to pass, et cetera, et cetera. And this is all about working in small batches. It's all about taking the baby steps, and it's really the secret to going fast. So if you look at the red-green development, the red-green factor development cycle, it's what Uncle Bob was showing. So the first step is to write a test that is simple as possible and fails. So it's got to be useful. It's got to actually test something and validate that something useful happens, something valuable happens. But at first you see it fail. And note that it's really important that you see the test fail first. A failing test actually validates your understanding of the problem. I've made this mistake. Oh, I wrote the test, and it's like, oh, look, it passed the first time. Well, that's good. It's like, oh, wait, is it really? Because this test was supposed to fail. I didn't think this would work. And often I found that it's like, oh, wow, look, there's a logic error either in my test, like I copy and pasted something and did it wrong, or there's something in my code, my code under test that didn't understand. So it's really important to see it fail. Then you do the minimal amount of work to make the test pass. So you implement whatever you need to implement on the production code to make that new test pass. And this is where it takes a lot of discipline. Not to work ahead, not to say, oh great, I can see the solution that I want and implement it all there. Write down on a post-it, or don't worry, you're gonna get there soon enough, because it might be that the solution that you end up with will be better than what you thought, 5, 10, an hour, 10 minutes ago. And then the last phase is refactoring, right? Look at the code that you've written and see where you can improve it. So look for code that's duplicated or names that might have made sense when you wrote it, but now that you have a better understanding of what the solution is supposed to be, you can change things. And again, since you have this suite of tests that you've been building up, you can rerun them and make sure that all of the functionality behaves exactly as you expect. So, again, TDD is all about working in very small steps and giving you a continuously growing and evolving understanding of your code. Not only what you think it's supposed to do, but what it actually does by validating it. Now, for some of the things that we do in this class, some of the pair programming and maybe even Project 1 and stuff, this might seem excruciating because you're just like, oh my gosh, seriously, this problem is that hard, I can just bang implement it. Which is true. And yeah, part of the what you're trying to learn here is how do I just implement stuff better. But a lot of what I hope you get out of the course is how to use these techniques like test-driven development for more difficult problems in your other classes or in other code that you write. So let's see here. Oh, we'll talk about integration tests next time because I want to get to some coding. Any questions about test-driven development? Nope. Okay. I think it's time for a break, though. We've been sitting here for over an hour now. Let's take a 13-minute break. Come back at 7:20, and we'll do some coding. Okay. So, in the first part of class, we began exploring test-driven development, or rather, you saw a lot of stuff about test-driven development, right? We talked about some scenarios, some given, when, then, to get us thinking, thinking about tests, thinking about scenarios that that we want our software to be able to meet. Then we watched Uncle Bob video about test-driven development. We learned about the red-green refactor cycle, where for test-driven development, when you write a test, you first see that it fails, then you implement the production code to make it pass, and then you refactor the code to improve it so that it's easier to work with going forward. And now it's time to start doing some stuff. So let's see here, in student PDF, it talked about how one can get started with all of this. So let me just walk through. Sorry, where's the code I was looking for? Great, yeah, great. So we're going to create a new. We're going to create a new project for the student. And remember, you create the projects on the CS Apartments Linux machine. So I'm going to go to my checkout here. And there is a script called create student project. By the way, it's completely optional for you. If you want to follow it at home, great. If you just want to watch, that's fine too. This is not something that you need to submit or even that you need to do. So you can run this, and then this will create a new project called student in your repository. So now if I do a git status, I see that the pom.xml has been changed, and we can just quick look at how the pom.xml has changed. There's another new project in here called student, and that student is the student project is in a student directory. So I am going to add pom.xml and student to git. And now we should see that they are all staged. Yep. And so pom.xml is staged, as is all these files for student. Student is pretty simple. It's got that student class that we talked about, but it's also got a test for student and a unit test for student and an integration test for student. We'll do integration testing next time. I think just for right now, we'll focus on unit tests. So now I'm going to commit this. And I'm going to push it up to GitHub. Cool. Oh, question there. What commands have been run so far? Well, there's a couple here in the student assignment. You might need to reload the PDF. I just added them like 10 minutes ago to create the student project. And then I added the newly created files to Git and pushed them to GitHub. And again, it's not necessary that you follow along with this part. This is similar to what we did last time when we created the cones project. And so you can always watch the video if you really want to play along. So over here on the left, so let's see, I am done on the PSU machine, so I will log out of over here. Here on my local machine, I have my checkout of the repository. So now I will pull the latest changes into that. And it got all the new student stuff. That's awesome. Now, actually what I'm going to do over here, I'm going to cd into the student directory, and I'm going to build the Maven project using Maven verify, Maven w verify. So what the verify phase does is that it builds the entire project, it compiles the source code, it compiles the unit tests, it runs the unit tests, it'll do the same for the integration tests, it'll run all the stuff and verify that, yes, all of your code builds as expected. We'll dive much more into detail on this in a couple of weeks when we talk about continuous integration. But Maven Verify is like the soup to nuts, do everything that you can. And we saw some stuff go by. We saw the unit tests run right here. So student tests ran. There was one test that was run. Everything passed. That was great. And then we also saw some integration tests go by, the student IT. Also same thing. One test was run, nothing failed. Super awesome. Okay, so all of that's built. Now I'm going to go back to IntelliJ. And when I open up IntelliJ, I am, let's close this down here. I'm going to synchronize with the file system by saying reload all from disk. And when I do that, it detects the student directory, and it builds things. It analyzes all the POM files, the Maven configuration, and then it turns the student directory bold because it realizes that it contains a project, a Maven project. So let's take a look at what's there in the student directory. Here in my source directory, I've got a couple of things. I've got a main class called student. And this is the code that was, sorry, what is it? Oh. There we go. Command Shift F12 makes everything big. Here's the student class that that was described in the assignment. It's got the constructor that you're familiar with and the implementation here. So this is good. This is what we're going to, the code that we're ultimately going to implement. And then in the test directory, it's got a student test. Let's take a look at that. So this is a unit test. Now in the Uncle Bob video, he was using a super old, that video is pretty old now, it's probably close to 10 years old. A super old version of IntelliJ. It looks a little different, at least to my eyes. And he was also using an older version of JUnit, and he wasn't using Hamcrest. But I will, so I like using those libraries. Here we have a very simple unit test that tests the name, the get name method of student. So basically, the name of the test is student named Pat is Pat. So I have my variable name Pat, and then I create a student that with a given name, and then yep, take 0 classes and GPA 0, and we're not really testing it, we're validating anything right now about gender. So these two lines, like right here, are what I would consider the given part of the given when then, right? So this is like the scenario. You have created an object that is under test. And so now you've got that object. Now the when in this case is invoking the getName method on that Pat object. So, okay, call getName. And then the then is my assertion right here. So then I expect that the name, the value returned by pat.getName is equal to my name variable. Now, assert that and equal to are part of this Hamcrest API, which I talk about in the JUnit lecture. Hamcrest, it's matchers backwards. Hamcrest gives you, it's an anagram of matchers. A Hamcrest gives you a more fluent API for making assertions in your tests. So assertions are statements that you expect to be true. It's where you, the developer, codify how you expect your objects to behave. And in this case, when we create a student that's named Pat, we expect that the name returned is Pat. Now, this is a very simple test, but I want to make sure that it runs. So the way you run a test inside IntelliJ is that you can click on the little Go button here in the gutter, and it gives you a menu of things to choose from in terms of how you want to run it. I just want to do a straight up run. I don't want to debug or put it into the profiler or anything like that. I'm just going to run it. And then IntelliJ takes care of building the code, and then very shortly here, it will launch the test. And sure enough, it ran. So down here at the bottom, there's a run dialog section, I don't even call this thing, panel, that talks about the test that ran. So this is the name of the test is student named Pat is Pat. And actually, if you double click on it, it'll take you right to the declaration. It's inside of student test. And this is where you can get information about how the test ran. And you see lots of green check marks and also a summary test pass, 1 of 1 test pass. So this is how you know the what your test did and how well it did. So in Java, your tests are in a different file than your code under test. What I like to do is this is the way I like to edit things. I like to do a split and move right. So here in one view, I can see my unit test on the right and my code under test on the left. That's just how I like to do it. Okay, so that is our first unit test, or it came out of the box. Now let's start writing some other ones. So let's go to the scenarios that you brainstormed here for the student class. And let's look to implement. Actually, we'll do for the rest of the class tonight. We'll spend the next, 45 minutes or so, implementing these tests to begin to bring our student class to life. So I hope you still all have the document open. Where do you recommend that we start? What would make for a good first test case for us to implement? So like, what is the simplest thing that we could implement?
Maybe no arguments.
No arguments. Oh, that's interesting. So let's write that test. I like that. So what should actually which scenario? Sorry, does that correspond to? Is that like number 4 right here? No, that's an empty argument. Is there one with no arguments?
Oh, there isn't. That's interesting.
Well, and like I'm really glad you brought that up. So like, what? That's a good point. It's like I can't create a student with nothing in it. So I need to provide a value for all of these things in the constructor. Now it could be null. Or maybe this one with like an empty string right here. So let's see here. So when all I do is provide an empty string, and oh no, sorry, it's an empty string just for classes, and then a GPA and a gender. Okay. So yeah, I guess these have stuff for all of them, or they have values for all of them. Well, let's start at the very beginning. Very good place to start. Well, let's see here. Here's the first. Here's like number 2 here. Oh wait, so well, actually no. How about this one right here? Let's take number 1. Any valid value of name, classes, GPA, gender, and when student when the says method is invoked, the result is this class is too much work. All right, let's do that. So I'm going to call it all students say this class is too much work. Now, one of the pieces of feedback that I've gotten is that I write very long test method names, and that's true, and I do that on purpose. We're not working on punch cards anymore. Disk is cheap. Compilation is fast. What we're optimizing for is the human. What we're optimizing for is the person who has to read your code, which is probably you. And I find that it's worth taking the extra time to express yourself accurately so that you know what the hell you were thinking when you wrote this code. So don't be afraid to write a complete sentence in camel case to when you have when you're writing your tests. So how do I express this? All students say this class is too much work. Well, I'm going to create a student. And I'll just call it student equals new student. And let's see here. The name will be, it doesn't matter what the name is. We'll just create a new empty array list. Double GPA, whatever, 3.98. And then gender, we'll say female. Why not? Okay, I believe that's a valid student. And then we're going to assert that student.says is equal to this class is too much work. Actually, is there? Yeah, there's no punctuation or anything like that there. Okay. Sorry? I have an E? Sure. It doesn't really matter, but you're right. Cool. Okay. Yeah, one of the problems with the split screen is that it doesn't all fit on the page, so maybe we'll just do this for the time being. Okay, now I'm going to run this test and see what happens. Aha, okay. So now I ran my test, and I see all the red, and it says, oh, look, test failed. Well, that means it failed. And while it ran the test, there was an uncaught exception. And here is the stack trace for that exception. So here I am executing my method. All students say this class is too much work. And I can click on this line right here to see what was being called. And I can look at it and say, oh, great. Well, the says method, and IntelliJ is nice enough to underline that in red, something bad happens. And now I can drill into line 34 of student. Oh, yeah. to see that right now out of the box, it throws an unsupported operation exception saying not implemented yet. Okay, so now, oh look, I have my red hat on, and what can I do to make it pass? Yeah, have the method return the string that we want, which is this class is too much work. Now I'm going to run my test again and see how it goes. Nice, it passes. Okay, that was through the green phase. Now refactoring. I don't know. Do we see an opportunity to refactor any place? Oh, okay. So yeah, you wanted to say, hey, look, because look, we have like two students that really could be the same, right? Is that what you're saying? Like this student right here and this student right here. There's really no reason for them to be different. So can we just create that once? I like that. I like that idea. I think it's worth pursuing. And we've got someone in chat weighing in also. Move assignment to student assignment to constructor. Oh, of the yeah, of the student test. Yeah, maybe like that's what Uncle Bob did. Um, I could. Yeah, yeah, yeah. So like I mean, like what Uncle Bob did is he would have said, well, instead of having student be a variable that's declared here in the method, he would put it up in a field. Actually, he used a refactoring. So actually, I'm going to do two things right now. Now we're going to cover this all in much more detail later, but I'm going to use one of IntelliJ's refactorings just to show it off for a point of demonstration. I'm going to highlight this code right here, and I'm going to go to the refactoring menu, and I'm going to say introduce a method from the highlighted code. And okay, and I'm going to call that method create student with the given name. Oh, what is it trying to do? It's trying to be helpful and tell me if I added more parameters, then I could use it over there. Well, I don't want to do that quite yet. So instead, I'm going to say keep the original signature, which is the one I asked for, create student. So IntelliJ automatically creates this new method for me, right? Saves me all of that typing. Helps with my carpal tunnel. And so then it's a create student method that creates a new student with the given name. And now what I'm going to do is in here, I'm going to create student, and then, I don't care, any old name. So I'm going to reuse that method, that newly created method. And now I'm going to run all of the tests in my class just to make sure they still run after that refactoring. Yeah, I'll show that up again. So what option under refactoring was that? Refactoring menu, introduce, extract/introduce method. Command Option M on the keyboard. Oh, and look, good. All my tests still passed. Very nice. Oh, actually, it said it only ran. No, it only ran one of them. Should have run. I thought it meant to run all the tests. I thought it did. Yeah, there you go. Now both of them passed. That's good. And we were also talking about having a student field. Okay. So here I can go to refactor and I can say extract field, and I can say I don't want to initialize in the current method. Instead, I want to put it in a setup method, which is a JUnit thing. You can have a setup method. And okay, now I have a field called student that has the value of create student. Oh, but with name. Yeah, and so like I can't. Well, I could use that same student here instead of Pat. I suppose I could just say student. No, but wait, no, I can't really do that because if I did that, it's not going to pass now, right? Because I'm not passing. So that student doesn't have the name of Pat anymore. Yeah, it said. I mean, the test fails now because what I'm passing in here, this field doesn't have the value of Pat. So okay, I don't like this. I'm going to undo that. And honestly, I don't know if like having this as a field really buys me anything. So let's see here. Can I easily convert this to a local variable? I don't think I can. So I'm just going to undo my way. Yeah, back there. And so I don't set method anymore. Okay. Well, okay, I just messed around with the code, and it's fine, right? Sometimes you start refactoring something, and it's like, it didn't really work out. That's okay, right? Because what you've got is you've got unit tests to make sure that everything still works the same after you've been messing around with your code. Yay! Okay, great. That's pretty cool. Okay, so we wrote a test and saw it fail. That's the red. We made it pass by implementing some code. That's the green, and we refactored it. And so now the code is a little better understood and hopefully easier to work with. Once I have green tests, I like to check things in. I like to have lots of little commits. So added a test for the says method. And so I'm going to commit all my changes to GitHub. I'm going to push them up by doing commit and push. And do note that all these green pop-ups at the bottom of the screen, I have a plugin to IntelliJ that sort of tells you, here's all the stuff that I'm doing, here's all the stuff that I'm clicking. And here's all the keyboard shortcuts that I use. So I use a lot of them. Okay, cool. We got the says method. So we're going to call this one implemented. I'm just going to highlight it in the background color. I'm just going to highlight it in a very nice shade of blue. Nope, not that shade of blue. I just use it above. I will highlight it. I'll highlight in green because it's passing now. So light green. There you go. That's not very pretty. Okay. What's the next one? Test case number 2 is interesting because this is like the end-to-end test, right? This is like the big thing. If you get this thing passing, I think you've pretty much got everything implemented, or at least got the happy path implemented. So, you know what I'm going to do? Since we know what this path is, I'm going to go ahead and implement this, but we know it's not going to pass, not for a long time. So I'm going to call this, I don't know, complete Dave student. So let's see here. This student is Dave, and a new student named Dave that takes some classes and has a GPA, and actually the GPA is what, 3.64? 3.64, and then the gender is male. Now I can have IntelliJ, so I just created I want to create a variable here. And so I hover over it, and it says, like, I don't know what this classes thing is. That's okay. Hey, IntelliJ, would you please create me a local variable? Oh, good, and it does. It creates me a new array list. I want to hit return here, so it's blue. I'm just going to create a new array list. And now I can't remember the names of the classes that I take. So yeah, algorithms, operating systems in Java. I'm just going to copy and paste here. I say classes.add all those folks, and then I'm just going to, it's got fancy quotes. Nice. Okay, algorithms, and classes.add operating systems, and then classes.add Java. So you might not have had a chance to learn about the collection classes yet. This will be coming, I don't know, it's in an upcoming lecture. I can't remember if it's next week or the week after that. But they're really great. This is how you group, multiple objects into another object. They also have these generic types. Say, hey, this is an array list that contains strings. You'll be learning about that also. Now I've got my Dave student, and I want to assert that when the Dave student's toString method is invoked, it ought to return this whole thing right here. Oops. So let's see here. Dave has, I want to say equal to. This whole thing. Dave has GPA of 3.64, is taking 3 classes, algorithms, operating systems, and Java. 2 spaces after a period, because I'm old. He says this class is too much work, period. Nice. So this is ultimately what I need to do, right? This is like the end-to-end. And let's see where we're at. I'm going to run this. I could fail because, oh yeah, toString is not implemented yet. That's okay, right? This is exactly what I expect. But I like writing this test for a couple of reasons. First of all, in writing this test, I understand what the end-to-end functionality is supposed to be. This helps me understand the problem that I'm looking to solve. And from the outside, how my student class is going to solve that. I also like having this test so that as I continue to implement other functionality along the way, I can go back and say, well, how close am I to my goal? Oh, maybe this will help inform what I should do next because I've got this essentially an end-to-end test that tests all the behavior of the class, which is essentially all the behavior that's there in the toString, right? toString has a GPA, it has the classes have commas, and the Oxford comma, and then, right, and oh, it's got like the pronoun, right? So this has everything that I need. This is how I know I'm going to, and this is me demonstrating that I've got everything done. So this is a lovely test, but it's going to fail for a long time. Now, what could I, and so I don't want to have a failing test, so what can I do? Yes, I want to ignore it. Now, I could comment it out. Why wouldn't, what would be a disadvantage of commenting out the code? Yeah, I forget about it. Also, let me something else here. Yep, yeah, I might forget to undo it later. Also, if I were to make some change, let's say I changed something about the student. So I said, maybe I don't know, I change the type of classes, or maybe I represent the gender in a different way. If it's commented out, the compiler's not going to tell me that it's broken. So I want to leave it in, but I just don't want to run it. And so then the way you do that in JUnit these days is that you have a disabled annotation that you put on it. And now when I run all of my tests, it shows the two that are passing. I can also turn on ignored tests. And so great, it's still, the code is still there. It'll still be compiled. It's just that the JUnit framework won't run it. Yeah. Yes. Yep, it disables the following test. Correct. Yeah, so if I add another test here, and hey, let's do that. It'll still run it. So let's see here. I think the next test that I want to write is toString contains student name. So how do I do that? I create my student, create student with a given name. I'm going to use, on the Mac, it is Option Enter. On Windows, I think it's Control Enter. I use it every day, I should know. To create the variable, the name, I'm going to call it name. And then I'm going to assert that student.toString, so the result of toString contains string. I'm going to import this. Oops. I'm going to import this from Hamcrest. I'm going to assert that it contains a string name. So now I'm going to run this test. I'm going to start using keyboard shortcuts, but I'll show it one more time. So the keyboard shortcut for running a test is Control-Shift-R on Mac, Control-Shift-F12 on Windows. And it fails. So it fails because the toString method isn't implemented. Okay, sounds good. How can we get this to pass? So clearly we want to delete this, but what can we do to get this to pass? And remember, what is the simplest thing that we can do to get it to pass? Oh, interesting. We'll return what string? So we just return like the string name. And maybe this is an okay thing to do. This seems a little silly, but I don't know. Oh, look, that passes. But that's not really what we want. What would be another test that we could write to force us to do the right thing?
Return name without the quotations.
Oh, okay. Yeah, okay, I was thinking about another test we could write. Did you have an idea for another test? Yeah, right, yeah. So we could, we could do something like, oh, maybe Dave's two-string for Dave returns, contains Dave. Right, so now if I run this test, it's going to fail. Okay. So yeah, I think the suggestion from that was, oh yeah, have a return name, and apparently there is a name. Now I can control click, or sorry, command click on it, and I see that, oh wow, look, it brings it to the declaration, which is up in the animal class. Wow, okay. Is there a way there's a way that you can view the class hierarchy in here. I don't know how to find it, I'm too lazy to look for it. So, hierarchy. Hierarchy, what does that do? And if I go and look at animal, does it show it? Oh, maybe because it doesn't show because it's the project. Or what if I go back to student and I go to the student class to show the hierarchy? I don't know. Okay, never mind. Doesn't matter. Okay, so it has access to the name field. So let's try running it again and see what happens. Well, that worked. And I'm going to try running all the tests again to see if they work. Nice. Okay, well, that was red-green. The opportunities to refactor. Sorry? Again, please, I just can't hear you. Oh, yeah, right. Yeah, do we still need both of these test methods? I don't think so. Yeah, right. They're exactly the same thing. I think I'm okay with deleting them. Unless they somehow they're, inadvertently reproduce things, or reintroduce things, but I think we'll find that stuff. Okay, cool. Okay, nice. This is good. Red-green refactor. Okay, let's commit the code. And I'm going to commit this here, and I'm going to say toString contains the student's name. Push. Now, again, at some point tonight, if you haven't already, you're like, oh my God, this is so slow. You're not wrong, right? And, I am deliberately going through these steps to show you the discipline of test-driven development. Because as you start working on your projects, especially the later ones that get more complex, you'll want to take this approach because there's just more things to consider. All the slowness now in development saves you this time and more in debugging. Trust me on that one. Okay, so now we've verified that toString contains a student name. What should we do next? Want to do GPA next? GPA next. Okay, so similarly, let's see what this looks like. toString contains GPA. Okay, so now we need to create a student. We can't use the create student method anymore. So let's create a new student that has a name. Don't really care what the name is. Don't really care how many classes we're taking, so let's make a new array list. I do care about the GPA though, and the gender is other. Okay, I will create a GPA, and we will call it let's have a valid one, 3.45. And then I'm going to assert that student.toString contains string GPA. Okay. This isn't compiling. Why isn't it compiling? Required type. Okay, requires a string, but it gave it a double. Well, that is true. So now I need to convert that double into a string, right? A double and a string are not type compatible. Does anybody remember off the top of their head how to convert a double to a string? Cast it to a string? Let's give it a try. Apply some science to the situation. Cast it to a string. Yeah, it still doesn't like that. What does it say? It says inconvertible types cannot cast a double to a string because a string is not a double. Okay, fair enough. Or a double is not a string, rather. Yeah, string.value of. Nice. Yep, this is one way to do it. This is a good way to do it. So this is why you got to know your APIs, right? So the string class has a static method called value of that converts it to this double. Actually, so value of is overloaded to take basically any type of data, including a character array, and convert it into a string. So now the code is happy. It compiles anyway. Yeah. I just hovered over it. Yep. How do I turn it on? Oh, I didn't realize it was off by in some cases. Okay. I'm not sure. I bet it's under settings, which is preferences here, and tooltip. Hover. Show code lens on scroll bar hover. I don't know what that means. Show full path on mouse hover. Code scheme general hovered. That's color scheme. Sorry, I don't know. Oh, hoverboard is one word. Good to know. Probably a lot of people who have hoverboard in their code. But anyway. Yeah, sorry, under code editing. Oh, yeah, probably, there it is. Show quick documentation on hover. So under the code editing section in preferences, I bet that's it. Yeah. One of the things that I've found is that my IntelliJ has inadvertently been, or unbeknownst to me, sort of like been customized to a lot of things. So I've been using it for so damn long, and so then they're nice about those of us who are old and set our ways. It's like, oh, you've been, we'll keep the old defaults. That's cool. But then people that are starting off are like, hey, listen, there's probably a better way to get started. So yeah. Okay. So then let's run this code. ToString contains GPA. It fails. It said I expected a string containing 3.45, but was name. Okay, what does that mean? So the assertion failed. So there wasn't like there was I guess it kind of was an exception thrown, but it didn't come from the code itself. Instead, ToString returned just fine, but it contained the string name instead of something containing 3.45. Well, why was that? Oh, yeah, it's a good point. Yeah, right now the implementation of string is returns name. So what do we need to change it to do? Include the GPA. Great. Okay, and I'll just use string concatenation here. Well, yeah, that's a good point. Yeah, GPA is passed in as a double, but if I use string concatenation, like the concatenation operator, I can just say, GPA here. So, okay, nice. It's got the name and the GPA. I'm going to want both, right, in the string. So, cannot resolve symbol GPA. Well, that is true. I don't think we've declared a field. There's no variable. There's no field for GPA. Let me make this a little bigger now because we're over here on the left. So I want the GPA in there, and I pass GPA into my constructor, but look, it's grayed out. And if I hover over, it says, oh yeah, parameter GPA is never used. That's true. I pass the constructor and don't do anything with it. So what should we do with it? What should we do with that GPA that we're given? Yeah, assign it to a field. Awesome. So I will just say, oh, actually, you know what IntelliJ, I learned IntelliJ can do now. I think it will, if I do show context actions, it'll say create field for parameter GPA. Thanks, IntelliJ. And I'll call it, GPA, and I want it to be final because it's only going to be assigned to the constructor. Nice, and I've got a GPA. And now, actually, if I look at my code editor, I'm going to minimize myself here. It's got 2 warnings, but no errors. Oh yeah, saying classes and gender are never used. Okay, well, we'll get there eventually. Okay, great. Oh, and now there's no red down here. Cool, I'm gonna run my test again. Hey, it passed. Okay, I'm gonna go run all of my tests again. I'm gonna rerun all of the tests and student tests. And hey, they all pass. Awesome. Okay. Red, green, refactor. See any code that's duplicated or anything that we can change? What did I change it here? I added the field. Let's see. I don't see any opportunities to refactor. However, I look at this implementation of toString. Is that what we want? Let's concatenate the name, the GPA. It makes all the tests pass. Doesn't seem like the right thing. So what should we do in this situation? Sorry? Yeah, we could format it. Before we do that, we're doing test from development. What's the first thing we should always do? Write a failing test. Exactly. So what is the behavior that we want out of the toString? Right, yeah, name has a GPA of. Okay, great. So toString contains name has a GPA of yay. Okay. So I am just going to take this code right here and copy it and modify it a little bit. And I'm going to say, oh yeah, I want to put the value of this name into a variable. So can I assert that? Yeah, there. And I can use refactoring for that. I can say introduce variable. I'm going to call it name. And now I'm going to say that, let's see here, I want to say name plus has a GPA. Is it lowercase? No. Has a GPA of GPA. Cool. Now this is what I expect. So I'm going to run this test. Nope, it failed. Okay. Expected a string containing name has a GPA of 3.5, and same said was name 3.5. 3.45. Okay, great. So now I can just fix this by saying has a GPA of GPA. I'll run this again. Oops. Missing a space right there, so it's going to fail. But look, it told me right away. I had a typo, and within seconds of making that typo, I found it. This is why you unit test, because I make dumb mistakes like this. Because I'm getting tired, I'm going fast. It's another time. It's but I found it. So here we go. I'll run it again. Yay! It passed. I'll run all of them. Yay! They passed. This is what test-driven development's all about. It's getting this really rapid feedback, and yeah, maybe you'll go back and watch the video and say, "Wow, it's a long time to write like 2 lines of code." But along the way, I know those are exactly the right 2 lines, and I can find the next opportunities, the additional stuff to write, and I can be very confident along the way that I'm doing the right thing. Question? Yeah. Yeah, on the let's put it all up there. Yeah. So assert that when I call student.toString contains a string name plus has GPA of GPA. Yep. Actually, you know what? I'm going to. This is another good place to extract a variable. I find it's a little hard to read. So I'm going to create a new variable here. I'm going to extract a variable. I'm going to call it expected. I'm just going to call it expected. Expected string. And I'm going to add some white space to make it a little easier to understand. Nice. A little refactoring. And I'm going to run this again. I can do rerun test with Command R. Good to know. Cool. Still passes. Okay, great. Okay, now I am going to commit, and I'm going to say has student's name and GPA, and I'm going to push it up there using all the command shortcuts or keyboard shortcuts. Okay, this is cool. Okay, we're getting there. Okay, so then what's another test that I could write? Want to just keep writing the toString? Right? I mean, I don't know, that's a reasonable place to go. Oh, validating GPA. Yeah, say more about that. So like, yeah, what does it need to have a valid GPA? Yeah, okay, so yeah, between 0 and 4. Okay. Actually, that's a good point. Yeah, we really haven't done that much with like negative test cases. So far it's been like, yay, good things work as I expect, or rather, things work with valid input. Let's talk about, invalid input. Okay, I like that. Okay, so let's see here. Void when GPA is, I should probably GPA is negative. What happens? Like, what should I expect to have happen? Sorry? Throw an error? Okay. Huh? Oh, good, great. Yeah. Throw an exception, print an error. What's the right thing to do here? That's a good point. What should we do? What does it make sense to do here? And why would I choose to give an option? Or rather, what are some of the pros and cons of each of those options? Okay. Yeah. Okay, yeah, that's a good point. Okay, so if we were just to print out an error message, you'd still be able to create a student object with an invalid GPA, but then like we would have to rely on someone seeing the error message to know that, oh, it's kind of a bogus student, you shouldn't work with it. Yeah. So it's like printing out, I mean, there is a time to print out error messages, but maybe like creating the when you create the student, it isn't that time. Because I mean, interacting with standard error and stuff is like what the main, what's all part of the second scenarios, that second table of scenarios that we'll look at next week. So yeah, I think it's more appropriate here because we're dealing with the code, not so much the user interacting with the program. So I think, yeah, it's more appropriate to throw an exception. So when GPA is negative, an exception is thrown. Nice, okay. So let's do that. So let's make ourselves a GPA and of minus 1.23. And let's create a new student. Well, actually, let's see here. New student. We're actually not going to create a student. We'll never get an instance of it. So let's call it name, new array list with a GPA, and other. Oops. What did I do here? That. And let's see here. When this thing is invoked, it should throw an exception. So what kind of exception should it throw? Ooh, illegal argument exception. I like that. Yeah. Illegal argument exception. So So yeah, this is a pattern that you follow right in your unit test. So I'm going to perform some operation. I expect it to throw an exception, and I want to make sure though that if it's well, actually, let's run this code the way it is. Oh, it passes. Ew. Right? Yeah, right now, like Uncle Bob's got a tear coming down his eye, right? Because you didn't write a failing test. So why didn't this test fail? Yeah, right. The constructor doesn't validate it. Now, I'm supposed to be able to write the failing test without modifying any of the production code. And so then what I need to do is I need to say, well, if it was possible to successfully create the student, then the test should fail. And I can implement that by calling a method called fail um, from JUnit, and I should say should have thrown and a legal argument exception. Otherwise, catch pass. Yes. Yes, there is. You've probably listened to the lecture. Thank you very much. Yeah, I'm going to get there shortly. Right. So then I'm going to run this test again. And I expect it will fail. And it will fail with my, oh, look at that. Assertion, failed error, should have thrown a legal argument exception, and argument is misspelled. But what she just pointed out was that there's a better way to do this in the let's see, in the JUnit API. You can say the following. You can say assert throws, and then assert throws takes two arguments. One is the type of exception to expect, which is a legal argument exception, and you give it the dot class for that. And then the other thing is an executable. So I'm going to create, no, I'm not. So I'm going to use what's called a lambda expression. You'll learn about this in a little bit. And what this basically does is lets me just execute some code. There. And now this will pass if it indeed throws the exception. I don't need any of this boilerplate anymore. This provides a much better error message, and I don't need to worry about calling that fail method. So now when I run this code, okay, it fails. And again, it gives me kind of a nicer message. Expected a legal argument exception to be thrown, but nothing was thrown. Great. Okay, now I'm happy with my red test. And so, okay, how do we make it green? What do we need to do and where? Well, here's my my GPA. So I'm going to do the following. I'm going to say I'm going to validate the GPA before I assign it. And oh, I just said I want to create a method, or I just want to have a method there. I can use the context actions to say, hey, create a method. I'm going to do that. It creates the method for me, which is really nice. And then what do I want to say here? So actually, what do I want to put here? How do I want to validate the GPA? What code should I write? Okay. So what do y'all think about this implementation right here in this moment? Yeah, it's amazing, totally. Oops, legal argument exception. So I believe this is this is the correct implementation. Actually, I probably would have done this here to make it a little bit more clear. However, from a strict TDD point of view, it's a little overkill, right? Because we don't have Well, actually, maybe it's not. Well, I guess with this, because like we don't have tests for greater. Oh, so we don't have tests for greater than 4. But is that too constraining? Because otherwise, like if we wanted to write the minimal code just to make this work, we would say if GPA is less than 0, then throw the illegal argument exception, else return GPA. You know, I'm probably being a little pedantic here, but I'm just going to do it for the sake of demonstration. So like, right, you know, this would be literally the smallest, you know, piece of code that you could do. Probably what I would have done is, yeah, I would implement the whole thing where I'm like, oh, wait, before I run it, I got to write another test too, just to make sure. So like now when we run it, it passes because the legal argument exception was thrown. And I think the next thing I'm going to do now is create the is greater than 4, greater than 4. Exception is thrown. That's 5. So then I'm going to run this. Ooh, is there a way to parameterize tests? Yes, there is. And I'm torn because on the one hand, yeah, but you know, it removes a lot of boilerplate. So there's some times where a parameterized test is just exactly what you want. And then other times, I kind of feel it gets in the way. It makes it a little hard to read because you end up, so much of the code is more about like this fixture that you create. And here's all the data that you send in. It confuses me. It's like I can't, they seem very far apart in my mind, especially when I'm reading someone else's code. So I use parameterized tests judiciously. Yeah. Because I think I'd rather sort of be able to look at it in isolation and understand what it's doing than trying to understand it too much. But it's, I don't have hard and fast rules there. Okay. Now we just do this. Say or GPA is greater than 4.0. Yeah, okay. So, you know, a little extra step, but now I've got more code coverage. Okay, everything's running now. Nice, okay. Validate that the GPA is actually, and you know, I'm glad you called that one out because this is something that you do very commonly in tests. You exercise the boundary conditions, which is it's just good to know. It's good to think about, and it's good to make sure that your code reacts in an understood and expected way when it gets bad information, right? You know, maybe it will, you know, maybe it'll never get an invalid GPA, but if it does, at least you'll know what to expect, and there'll be a test there to guide people. And I guess one of the things that I didn't really talk about, tests are, in many ways are documentation. They express what your code is supposed to do, and they can express it in a way that is, well, it's executable. And so then it's, you know, very, it's not exactly, it's clear, it can be clear. If the code is clear, then the expectations are clear. I guess it's very demonstrable. It's very inscrutable. I don't know what the right word is there, but it's like, hey, you know, it goes and does it. Nice. Well, we are at the end of our time box for tonight. It is 8:20. I believe that's the official end of class. So let's end it. But thanks for going on this journey into test-driven development with me. We'll cover more on Wednesday night. Once again, Wednesday night everybody will be remote. What I will do, I think, on Wednesday is let's go into the integration test. We'll talk about how to test into the command line. We'll take a look at the command line program. So we'll do that for most of class. And but then also another important thing for Wednesday is that we're going to learn about our first phase in the multi-phase project and talk about our expectations for testing and documenting it. So more sort of like lecture and handout stuff next time, but definitely more test-driven development with a focus on integration tests. For the awesome. Okay. I will see you all on Zoom then. Bye, everybody.